Good morning or afternoon, whenever you're watching this. We are on week 9 for Algebra Lesson 6.1, Slope Intercept Form. This is going to be a review of sorts. We are going to be going over linear standard form, which we've gone over in the past. And we've also in the past briefly touched on slope intercept form. We will be going into more detail with that. As far as the vocabulary is concerned, linear standard form is a way of writing a formula for the linear equation in terms of ax plus by is equal to c. In other words, in order to write an equation for a straight line on a graph or a line in general, we usually want to write it in this way. However, there's another way that you can write the exact same formula. You can change it. You can solve for the y and make sure that y is by itself. And in that case, you end up with something called slope-intercept form. Slope-intercept form is a transform version of a linear standard form in which uh, we can use it to graph. Slope-intercept form is important because we use it whenever we're graphing, we use it whenever we're trying to determine the equation of a line using only 2 points, which are 2 skills that you're going to have to show for this week. Okay, so here, in case you guys forgot, I'm going to go over quickly a review for how to convert an equation from linear to standard form. What I was just saying, right? So let's say you are given a linear equation like what I have here. I have negative 10x plus 5y is equal to 25. Okay, so if I have this, one of the things that they're going to expect that you know how to do is the book is expecting you to remember what we talked about a couple weeks ago, which is if you have a linear form, do you know how to turn it into a slope intercept form, right? So I have the steps written out, right? So step one, the original equation, you just need to understand that equation is technically written in linear form. That's all I want you to know for step one. Step two, you can begin to isolate x by doing the inverse operations. The goal here is to make sure that y in general is left by itself on the left side of the equation, and all the x's move to the right. So in order to move the negative 10x to the right side of the equation, we need to do inverse operation, which is the opposite. Right now we have a negative 10x, and since it's negative, the opposite of a negative is a positive, which means we're going to have to add 10x to both sides, which is why I have this step right here. That's the step I'm talking about. So I added 10x to both sides. And if I'm going to do that, this cancels out, and I'm left with just 5y. I'm left with this part right here. 5y is equal to 10x plus 25. Now, the reason why I didn't add 10 to the 25 is because 10 is multiplying by x. I have 10x. And 25 is just a regular number, which means that they're not compatible. I can't actually add them together. So I kind of just pushed 25 to the side and I put 10x there. Again, this is all a review, but I'm just explaining step by step in case you don't remember. So once you're at this point, y is on the left side of the equation. It's not technically by itself. There's still a 5 in front of it, right? So now we're on step 3. Now that you're left with 5y on the left side of the equation and 10x plus 25 on the right side of the equation, you need to finish isolating y by dividing both sides by 5. We need to get rid of that 5. Since 5 is multiplied by y, we need to do the inverse operations, or the opposite. Opposite of multiplication is division. So we're going to divide everything by 5. So if you notice that I put a line underneath all the numbers, I put 5 so that we can cancel out this, and we are left with just a regular y on the left side of the equation, which is exactly what we want. And then that's going to equal to 10x divided by 5 is going to be 2x, and 25 divided by 5 is going to be 5. So in this case, right, we're left with an equation here. Now remember, this is now officially in y equals mx plus b, or slope intercept form. Again, this is a type of review. You should know how to do this, but again, it's been about a week or two since you might have done this. So we're going over it now. Like these are all things you should have in mind as you're moving into the actual problems. By doing all of this, we have converted a regular equation that's in standard linear form into slope-intercept form. And slope-intercept form is special because it lets us know how to graph any equation. As long as it's in this form, we know a couple things. M represents slope, right? Or the change in between 2 points. And B represents the y-intercept. Or it's the point where this line, remember the y, everything is representing a line on the graph, where the line meets the y-axis. Now, what I mean by that is I'm just going to give you a quick example. The y-axis is here and the x-axis is here. If I have an equation like this, right, and the line that I graphed looks like this point right here, where the line touches the y-axis, is considered my B, right? My point B. And the slope, right, is my rise over run, right? It's how many times I went up and how many times I went to the right to the next point. These are all concepts that we've already gone over. Okay, so let's move on. So what are you expected to do this week? All right, so you're expected to know to be able to write an equation in slope-intercept form, given two pieces of information. That is, the problem is going to give you coordinate points, and it can give you a slope, and they're going to ask, okay, what's the equation that has this slope and that passes through this line. So if you look at the problem, it says write an equation of each line in slope-intercept form. And all the information is the next information in bold, where it says slope is equal to -1 and 0.3, 2 lies on the line. So what that's saying is, okay, you're given two pieces of information. Can you plug this in? And can you figure out what the equation is? And can you make sure it's in slope-intercept form? So if you notice here on the side, I'm going to move this a little bit. Remember a couple things. M is equal to slope, right? And B is my y-intercept. Now, if you notice here, we're given our slope, right? We're given our slope. We know that M is equal to -1. So, okay, we have slope. Good. Then we don't have B. We don't know anything about B in this problem. Not yet. We're going to have to look for it. And as far as the coordinate points, X and Y, remember, a coordinate point, the 3 would be the X and the 2 would be the Y. So we actually have 3 out of the 4 pieces of information. Why don't we go ahead and plug that into the slope-intercept form? I'm right here where it says, right, Y is equal to mx plus b. We start there. You're going to always start with that formula whenever you run into a problem like this. Then you're going to plug in the information you know. You're going to plug in 3 for x and 2 for y, as well as -1 for m. Remember, if they give you different values, plug in whatever values they give you for that problem. So in this case, my y became a 2. So 2 is equal to, my m became a -1. So -1 times 3. My x is a 3 in this case, right? And I'm going to put that in parentheses because according to the formula, m and x are multiplying. So that's why I put them in parentheses, plus b. B is my last variable. And remember I said I don't actually know what b is? Well, in this part of the problem, I'm trying to solve for b. So this would be 2 is equal to -1 times +3 is -3 plus b. So in this case, I have 2 is equal to -3 plus b. And I want to make sure b is by itself, because remember, I'm trying to solve for b. So what I'm going to do is I'm going to add 3 to both sides, right? So I can get rid of it, which means that this is going to cancel out and the 3 is going to be on the other side. So 2 plus 3 is equal to 6, right? So that actually means that now I know what b is in this case, which is good, because now that I know what b is, I can plug in the value with m to find the final equation. What I mean by that is this problem basically asked, they gave you two pieces of information, and they asked, okay, if you have these two pieces of information, can you give me an equation in slope-intercept form? Well, in order for an equation to be in slope-intercept form, we need x and y to be blank. Because remember, in theory, you should be able to put any value for x, and you'd get the appropriate y. So x and y can be taken, but you need m and you need b in order to be able to solve for x and y. So what we're going to do now is, now that we know that b is equal to 6, we're going to replace b for 6. We're going to replace -1 for m. And then that'll be our final equation. So if you notice, my final equation is y is equal to -1x plus 6. That's the final equation. It's currently in slope-intercept form, right? And we've solved the problem. If all the problem is asking you is to just write the equation, you're done at this point. However, if the problem asks you for something else, if it asks you a graph, then you're gonna do this, but right, but you're gonna have to make a table and make a graph, right? So here we're using the same premise as we were doing that. What if the problem asks us to graph the equation and it's in slope-intercept form? Well, in the last problem, we saw that m is equal to -1 and b is equal to 6. We're gonna use this information. We're gonna make a chart. So if you notice, the chart has x, they have a space, there's y equals mx plus b in the middle, and then there's x comma y as my coordinate point, right? So remember that we went over this, I think last week or 2 weeks ago. We have x is equal to -2, -1, 0, 1, and 2. If you're wondering where I got these values from, I made them up. I didn't get it. I didn't necessarily get them from anywhere, unless if the problem specifically asked me like, "Hey, can you use these as your x values?" Then I'll use those. In this case, I made them up because they're the easiest numbers to plug in. They're really close to 0. Like, notice 0. When you plug in 0 into x, it's gonna make the problem really easy. Plugging in a 1 and a 2 is gonna make it pretty simple. When they don't tell you what numbers to plug in, and they're asking you, hey, can you plug them in? You're going to want to pick easy numbers. You can technically, in theory, pick any number you want, put it in there, and you'd be able to graph it. But if you're graphing something, you want them to be pretty low numbers so you don't have to draw a massive graph. Okay, so with that in mind, I'm going to plug in, I'm doing the example here. We start with that -2. I'm going to plug that into y equals mx plus b. We know that m is -1 and b is 6. So y is, when we plug in x as -2, we're technically solving for y, right? Because we need the coordinate point. So y is equal to m, which is -1, times my x value, which is now -2, plus my b value, which is 6. So if you notice, -1 times -2 is, and we're right here, +2, plus 6 is 8, which means that my final coordinate point is going to be -2 and 8, what I just figured out. Now, if you notice here on the graph, there's a graph right here that I have. It's already done, right? But if you want to look, -2 is right here, and 8 is right here, and that's the coordinate point right there. So I put that coordinate point there. And then I did the same for -1, 0, 1, and 2. I plugged in those numbers, and if you notice, there's a pattern, right? Uh, as the x went down by 1, changed by 1, the y also changed by 1, right? If it went from 8, 7, 6, 5, and 4, right? Which means that our what's it called? Our equation is linear. We could graph it, and we're using coordinate points to graph this. So this is what, at the end, I graphed all of these. If you notice here, I graphed all these coordinate points here, and all those points are right there. So that is how we would graph it. Again, this is a reminder of how we can do this. Um, there is one more complication. In the last parts of the problems that you're going to do for this week, you're going to be given, instead of being given the slope, you're going to be given 2 points instead, and that's all they're going to give you. So the problem is, find the slope-intercept form for the equation that crosses both points 1, 1 and 3, 2. So if you notice here, you're not given a slope. You're not given an m is equal to anything. You are, however, given 2 coordinate points. So what can you use? You're going to have to use something we did a week ago. Use the slope formula. Now, if you remember from then, the slope formula is m is equal to y2 minus y1 over x2 minus x1. If you notice, we're given 2 coordinate points, and I labeled one of them. The first one, x1, y1. I labeled the second one, x2, y2. And I just put them into the formula, right? So my x2 is 2, which is why my 2 is there. 2 minus 1, 3 minus 1 is equal to 1/2. All this was to figure out what m is. Remember, my m is my slope, and we just use slope formula to figure out what slope is, right? So now we know what our m is. Then we're going to do an abridged version of what we just did earlier. We are going to start with y equals mx plus b. And now that we know what m is, right, we can plug in m to try to figure out what b is. Now, if you notice, I have a 1 and a 1 here, right? That's because in the previous problem, we had to plug in, sorry, where was it? Yeah, we had to plug in a coordinate point, and when we did this, when we're trying to solve for b, we need as much information as possible. And if we know what m is, we need to plug in what the coordinate point is. Now, in these kind of problems here, you have 2 coordinate points. If you're wondering, like, does it matter which coordinate point I put into this step here, right? We're right here. Does it matter which coordinate point I put for my x and y? No, you just have to pick one of them. You're going to end up with the same answer regardless. Um, I would always just pick the first one just because it's a little easier that way. In this case, the first coordinate point is 1 and 1, right? If for you guys, you see that there's a fraction instead of a regular number and the other coordinate point doesn't have any fractions, it might be easier to plug in the coordinate point that doesn't have any fractions. Again, it's up to you. You should, in theory, end up with the same answer. So it's up to you how much work you want to do. So here, as long as you guys show your steps, I'm okay with whichever one you pick. So here we have y is equal to mx plus b. We're going to plug in 1 and 1 for x and 1 for y. So we have 1 is equal to, I remember we just figured out that our m is 1/2. So 1/2 times 1, which is our x value in this case, plus b. Um, Anything times 1 is just going to be whatever you multiply by 1. So that's 1/2. So 1 is equal to 1/2 plus b. I have to isolate b. So I have to get rid of 1/2. Remember, if there's nothing in front of the number, it's a positive number. If it's a positive number, the opposite of a positive number is a negative. So I have to subtract 1/2. So if you notice here, don't be afraid don't be afraid of the fractions. Anything minus itself, no matter what the number is gonna just be 0. So 1/2 minus 1/2 is gonna be 0. We get rid of it, it's canceled out. 1 minus 1/2 is just 1/2. So in this case, we know that b is equal to 1/2, right? We know that b is equal to 1/2. So now what are we gonna do? We're gonna plug in our m and our b, and we're gonna have our final answer. So y is equal to mx plus b, right? We're gonna start over. Y is equal to, now we know that m is 1/2, so 1/2 x plus, and we know that the b is also 1/2. So we're gonna have 1/2 right there. Okay, that's it. That's the kind of problems that you'll be focusing on this week. Your homework and practice is going to be problems 5 through 14, right? With half the problems kind of like the first example, and the other where you're given a slope and a coordinate point, and the other half are going to be problems where you're given just 2 coordinate points. Make sure to check back in here or join me for my Zoom office hours, right? Um, yeah, join me for Zoom at 1:30 to 3 p.m. if you guys are having trouble. So good luck, and yeah, hope you had a great weekend.